Okay, so the second problem from quiz 5A, it says the 5-number summary for midterm scores for an intro stats class. I really hate, once again, they didn't tell us more information about that class, but whatever, is displayed in here. So we've got the minimum score that stats class obtained on a quiz, much like the one you'll be taking on Wednesday, 16. Quartile 1 was 32, median was 39, and the highest person got 48.5. So I'm guessing this is like a 50-point quiz. You guys feel me? I guess. Who knows what? Oh, did it say that? It's a good guess. Would you expect the mean midterm score of all students? So would you expect the average for this data set? We can't see the actual data, right? We just have the 5-number summary. So just given that 5-number summary, what would you expect about the mean in regard to the median? Is it going to be lower? Is it going to be higher? Who's got an argument? John? I saw it.
I say it's going to be a lot lower because the quartile 1 is there's a big difference between the minimum and quartile 1, which means the minimum is possibly an outlier.
So there's a big difference here, like 16-ish, right?
Yeah.
So that's possibly an outlier. I like that. It's good thinking.
The mean's going to be pulled down more because it's going to be...
Up here, we don't have nearly the same difference, right? Much closer together. So this whisker, if we were to draw this box and whisker plot, which, by the way, on this problem, what's a really great strategy to solve it? Draw the box and whisker plot. You're going to see a really short whisker here. Then there's going to be a short little segment for the first part of the box. Then there's going to be a little bit longer segment on that side, and then a really long whisker. What shape does this have? This is skewed that way, which is skewed to the left. So the shape of this guy, I always like thinking about like a curve, is going to be skewed this way. If you drew a box plot, it should look something like this. Clearly a skewed to the left shape. Okay, so if it's a skewed to the left shape, what's the better measure of center? I know they didn't ask that. Or did they ask that in part B? No, they didn't. What's the better measure of center to use here? Median or mean? Median, because it's resistant to that skew or possible outlier. We don't even know yet how to decide if this is an outlier, but it could be, like John said. So that's one thing to keep in your head. They just said, which way is the average going to be? If this is the median, right, it is. There's the median. The average, is it going to get pulled up this way? Is it going to get pulled down that way? It's going to get pulled down this way. These really small values are going to exert an unusual influence on it, or more of an influence than they should, if that makes sense. So the average is going to be, I don't know, I mean, we don't know exactly, but it's probably going to be like somewhere like here, I'm guessing. You guys know what I'm saying? So you should have said something about lower. Based on the 5-number summary, are any of the midterm scores outliers? Here's how I show you how to do outliers for one of the two strategies that we just mentioned. So if you're using median and IQR, how do you detect outliers? Someone's got to know this rule from stats if you took it. Close. So you create fences and you see if stuff goes beyond the fences, if it's out of play, if you will. Okay, it's a very simple concept. So here's how you create the fences, and this I'm going to be very particular about. Any mistakes? No credit. It's very easy. Lower fence and the upper fence. The lower fence, you take the lower quartile, the 25% quartile. Because really, what do quartiles mean? This is key too if you haven't already thought about it like this. The median, or quartile 2, is the spot at which 50% of the data is below, 50% is above, no matter how much data there is. Quartile 1 is where 25% is below, 75% is above, so I remember it as 25%. And quartile 3 is where 75% is below, 25% is above. So the way you decide outliers, if you're using those, is you construct fences. Fence 1 is going to be lower quartile, and then you go down a certain ways away. The rule of thumb that you're going to want to use is 150% of the interquartile range. Of course, I'm using the spread to decide how unusual a data value is, if in fact it qualifies as an outlier. Upper fence is the same way, symmetric on the other side. Start with the upper quartile, the 75% one, and go up that same amount, 150% of the value we use for the spread. If something goes above that, it's an outlier. If something goes below that, it's not. Is that like a absolute Jedi type of truth? No, but it's a really good way to quantify weird. Something that's too weird to be considered typical. Does that make sense to you guys? So for this data, why don't you guys do that real quick? I'm gonna go 32 minus 1.5. The IQR was, what is that, 11 and a half? 30, oh no. 43 and a half minus 1.5 the IQR. Somebody feed me those values. What's this top one, the lower fence? Yeah, Montana?
Your second fence is supposed to be plus.
Yeah. I went the wrong way. Sometimes I drive down one way is the wrong way. Sorry. It's bad, right? What do you guys get for this one? Okay, you've got your fences. Make a decision. Do we have outliers officially here or no? Lauren, you're saying? No. No. Why? 14.75. Think about your smallest and your biggest thing. 14.75 is where? This way or this way? Is over here, right? The best way to do this is, actually draw a number line. Like here's our box plot. Here's the fence at 14.75. The upper fence is 60.75. That's clearly way up here. The entire range of data is between them. That means there's no outliers. Yes?
You said Mary Collins to students over there.
Yeah, in just a sec.
Thank you.
So, on your problems, when you're working on Chapter 5, they're on Moodle already. You might want to start them. You have no homework otherwise. I'll post them up there in a second. What if this number had been 18? Because I, like John, instinctively thought we were going to be close to having an outlier. We were close, right? Close but no cigar. So, good instinct. What if this number had ended up being 18? What would you say? Yes, there's an outlier. Yes, there's two outliers. Yes, there's three outliers. We don't have the data, so we'd have to say this. This I'd write down on your sheet. If that fence had landed, make sense for yourself. If that fence had actually landed inside the data, since we don't have it exactly, we'd have to say there is at least one outlier. We don't know if there's more. Does that make sense? Because the minimum would be an outlier. There could be more in there, we're not sure. Does that make sense, guys? Yeah. At least one outlier if you hit the fences. Unless you have the data. If you have the actual data, you can check each value. So. Okay, you guys should be set to start working on Chapter 5. When you do that is your choice. We'll finish that handout together tomorrow.